Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will continue with the cut protective textiles, and we have almost reached at the end, towards the end of the cut protective textiles. After cut protective, then we will take up another mechanical thread, that is strap protective textiles. So, in cut protective textile we are discussing the different characteristics of mechanical characteristics of this fabric. These fabrics are actually made with different types of yarn structure that we have discussed, and here the tear strength we see the fabrics made of the filament high performance fiber with the hard particle impregnated fibers, that we have discussed already. So, here we will see that the fabric made of hard particle impregnated filament results lower tear strength, and overall the glass core fabrics made of glass core has lower tear strength as compared to the stainless steel counterpart. But as far as cut resistance is concerned, that we have seen that hard particle impregnated fabric results very high cut protective performance. So, the improved cut protective performance is there with the hard particle impregnated fabric. So, this is true for all the different aerial densities, like in 150 GSM we have seen, in also in 200 GSM the cut resistance performance increases and hard particle impregnated fabric shows the highest cut resistance that we have discussed in last class also. Even this is the same trend is followed in case of 250 GSM, and SS core, stainless steel core gives very high cut protective performance around 3000, and glass core fabric around 2200. Now, we will see the microscopic image of the fiber. Here we have used the ultra high molecular polyethylene, and the main difference here it is a hard particle impregnated fibers, which is there in the ultra high molecular polyethylene. Otherwise, other fibers are remaining same. Here if we see the 200 denier without hard particle impregnation, but 300 denier fiber if we see, due to the hard particle impregnation there are the rough surfaces, that means the hard particles are there, and also in 400 denier there is no hard particles. So, this hard particles actually come into action during the cutting operation, and which typically blunts. So, this blunts this dulling of the knife, cutting knife takes place. So, hard particle impregnated fabric shows rough, this filament shows rough surface than other fibers. Here the basic mechanics is that the rough surface, and rough surface is not by the polymer, by a very hard particle, and that hard particle actually acts as a blunting agent of the knife. Now, if you see here, there are different particles we can see in scanning electron microscope. So, these are hard particles are visible here, and also in EDX confirms that presence of hard particle. This is W. In normal this polyethylene, that high performance fiber, this presence of W is not there, where that 2.2% weight, 4.2%, that presence of W is actually acting as the blunting agent. So, here now we can see the blades, this is a fresh blade without any serration, okay. The total smooth surfaces, but after cutting glass core fabric, when there is a glass core, we can see the scratching of the tip, blade tip takes place. So, it is there is also blunting is there. After this SS core, there is some blunting takes place. So, that is why this SS core and this glass core helps in improving this cut protection due to the blunting effect, and which is not there in case of this normal polymer. Normal polymers blunting takes place, it takes time, but when we introduce hard particle along with the glass core and this stainless steel core yarn, where there we can see this proper blunting in this at the tip is there. So, depending on the type of obstruction provided by the glass core or stainless steel core, and along with that the hard particle impregnation, the blunting pattern changes, and here you can see throughout the surface the blunting takes place, and the surface becomes totally uneven, and that is the reason of increasing the cut protective performance. Now, to conclude the action of the hard particle within the fiber filament, that high performance fiber. So, HPI, hard particle impregnated filament, enhance the fabric's ability to withstand cut resistance improve, blade blunting takes place, rapidly dulls the blade tip, which improves the protection, and tensile performance, basically tensile performance reduces. P is the modulus, maybe tensile strength, tear strength. So, reduces the tensile strength, especially at low density fabrics, that is, and higher aerial density, this averages out, but whatever tensile strength or tear strength we are getting, these are much above the required strength, standard strength. So, that hard particle, although there is a drop, but it is acceptable. Along with the tensile, tear strength is also there, but this tear strength there is a drop, but the tear strength is whichever we are getting, it is a much above the standard. Now, coming to the thermophysiological comfort of the cut protective textiles, which is very important. Here we can see the air permeability. Air permeability, this is Y3, Y6, we can see these yarns are made of coarser filament, coarser filament core basically, and that is why the yarn text is high. To keep the GSM same, we had to use lower thread density. So, lower thread density allows the air to pass through easily. Same trend is observed in case of thermal conductivity, that is due to the open structure with the coarser core filament. So, here the same trend is observed, and these are actually true for both. The same trend is there for both. You can see this is the moisture permeability also is higher. So, for both this glass core and the stainless steel core, we get the similar trend, okay. And here cut protective performance is also high, that because of the coarser thread, coarser core. So, the basic conclusion we can make, so we have to use little bit coarser core, that is coarser core filament, stainless steel or glass filament, which improves the cut protective performance along with the thermophysiological comfort, like moisture permeability, air permeability, thermal conductivity. So, at this point we will end the section of cut protective textiles. Now, we will start another mechanical thread, which is stab resistant fabric, and here we will discuss the stab resistant fabric and their testing along with the mechanisms, materials which are used, and what are the methods of testings. So, all these things we will discuss, and we will see the mechanisms of cut stab resistance are entirely different from the other type of thread. It is even the projectile impact is different from the stab resistance, and obviously cut mechanism will be different. So, detailed discussion we will do here, we will actually will discuss. So, an in depth look at the science, technology and rigorous testing protocol behind the modern stab resistant fabrics, how to develop, what are the different sciences that we will discuss, and what are the different testing procedure that we will discuss to ensure reliable protection against piercing thread. So, this is actually it is a piercing thread, bullet is impact thread. So, that requires different types of textile material. So, let us see the evolution of stab resist protection. So, in ancient armor, so protection began with rigid material like wood, leather, metal plates, which were effective, but main problem was that the bulky and its mass was very high weight and it was restrictive. So, body movement was not effective. What we want? We wanted light weight which will be comfortable. And another thing, modern threat has increased, different types of knife stabbing process, different types of structures have been developed. Many urban regions, stabbing and cutting incident result more penetration injury than firearm. So, firearm they also have a penetration impact, but the incidence of stab particularly in urban region. So, it is much higher than the firearm penetration. So, for that there is a need to have its solution. So, first solution was the polymer revolution. So, lightweight we need and higher threat. So, for that the polymer revolutions were there, shifting to advanced polymer. So, advanced polymer based fabrics were developed which allows to reduce the mass, weight reduction, which will be flexible, not like metal block or wooden block, and which will be comfortable. So, we need protection with a comfortable fabric. For that the advanced polymer is the main answer of this, and also there is a ergonomic design is required. So, contemporary design focuses on protective solution that can be worn and for long time. So, it is continuously we can wear, so worn discreetly and comfortable for long time. So, that is the requirement. With these requirements the modern cut protective, stab protective textiles are developed. Now, how this fabric works, the mechanism of stab resistance. The stab resistance material rely on the combination of high performance physics and material science, and this are required to actually dissipate the and absorb the concentrated energy. So, stabbing results the concentrated energy, unlike cutting, stabbing the concentrated energy. So, we need high end material science and physics to actually absorb or dissipate this energy. So, this energy is dissipated by fiber resistance. So, fiber will try to absorb this energy by high tensile strength like aramid, and also they are woven tightly to minimize the gap, so that the knife or any stab sharp material does not penetrate, forcing the blade to push through or break the fiber. So, there should not be easy piercing through the fabric. So, compact weave is required. Next is shear thickening fluid, the material science which has been developed. So, shear thickening fluid is also can be used. So, in case of bulletproof vest we have discussed. So, materials impregnated in shear thickening fluid instantly transform the liquid to solid upon high impact. So, high stab impact and which increase the resistance dramatically without increasing the mass too much. So, that flexible fabric becomes works like a solid, okay, at the time when high speed impact is there. Another solution is the multi-layer composite. So, stab resistance with single layer, it is very difficult to resist. So, layers are designed to distribute the stabbing force over wide area and preventing the concentration and penetration. So, this multi-layer they will help in distributing the load into the wide area. And fourth, which is very important for stab resistance, biomimicry. In the nature we will find there are different types of structures available, like designs are often inspired by nature structure. So, natural structures are there such as overlapping scales. Very common example is fish scale. You can see these are the scales. In the fish scale it is very difficult, it is not easy to pierce the fish scale through by the knife, although it is a very flexible. So, this type of structures can be developed which will prevent the stab, but it will remain the flexible. It offers the flexible with high localized penetration resistance. So, that is this is also can be tried. So, the fundamental components are the fiber resistance. First is that, so we will discuss this one by one the mechanism. So, first is the fiber resistance. First line of defense lies in the fibers themselves. So, because the load, whatever impact, pointed impact comes, the first it is coming to the fiber. So, fiber is the first line of defense. So, protective textiles rely on the extreme tensile strength. So, the fibers should have extreme tensile strength and also specific weave pattern. So, weave should not be very loose weave, open weave, because this penetration we have to restrict. And main issue is that we cannot have a clothing for only for the stab protection. So, we for multiple thread, that is a challenge, cut along with the stab. So, this type of structure we have to generate where the multiple thread can be, it can protect the wearer from multiple thread. So, high tensile strength like aramid, here we can see that for normal textile the tensile strengths are very low, which we cannot use, but for aramid, para aramid like Kevlar or high density polyethylene. So, this fibers results very high tenacity. Next is that tight fabric structure. So, high tenacity fiber we will be using and tight structure of fabric, otherwise there will be, if there is an opening there will be penetration. So, different types of structures we can use. So, high thread count So, coarser yarn we have to use and close knit weave pattern. So, which minimize the penetration gaps or path of least resistance. So, when some pointed object like knife tip it penetrates, so it should actually restrict that movement. So, high tenacity fibers are necessary for these cases to protect the sidewise cutting after blade penetration, that is also important. Suppose at the tip is trying to penetrate. So, there is a knife tip is trying to penetrate from the gap between thread, but this at the edge knife edge, by the knife edge this fiber should not get cut. Thus, there should be high tenacity. So, that force it should be able to withstand. If the fiber tenacity is less, so that this will cut apart and the knife will easily penetrate. So, we need both high tenacity fiber, high modulus, high tenacity and along with the tight weave pattern. To get higher stab resistance, tight weave knit structure is not sufficient to protect the stab thread, that as I have mentioned, though yarn that fiber should have very tight, very high strength. For further protection, so if we try to use the single layer, that may not be sufficient for to absorb the striking force. So, for that multi-layer fabrics or some surface modification with some coatings that we can add. So, add on the top of the fabric. So, some coating can be added which will enhance the stab resistance, which will prevent the knife edge or sharp object from penetration. Now, let us see what are the mechanical actions are there. Now, here is the penetration of object between the opening, but at this point at the side, from the side of that this knife edge, so there has to be higher friction. So, there that it should not get cut, and that is why high tensile strength is required. So, the structure force the blade tip to push through, stretch and attempt to cut the fiber. So, when it is penetrating, the blade, that knife will try to penetrate and the fibers get stretched and it will try to cut. So, in this passage the energy will be dissipated, and that is why the as it is penetrating, the range, the area becomes more and more. So, penetration will be restricted by dissipation of the energy with the more wide area. So, multi-layer composites are used. Instead, the system incorporates multi-layer system, distinct material layer, and each layer has to perform its own duty in critical role in the force management. So, there are different layers. Now, we can see this is the layer, this outer layer which performs the abrasion or which will protect the, it will be the abrasion resistant which will protect the main layer, stab resistance layer, the core layer which is actual stab resistant layer from abrasion, and inner layer which is in touch with our body, it is a comfort layer which will absorb the moisture, the skin touch sensorial comfort we can get from the inner layer. So, this composite approach ensures even if the outer layer is compromised, the subsequent layer will continue absorbing the load by distribution. So, distribute the stabbing force and systematically slowing down the blunting action. So, when it is a penetration, so each layer will perform its own action and gradually the force will be reduced and the energy will be absorbed, and also there will be blunting action of the knife. So, then it will gradually slow down, the stabbing process will be restricted. Now, how the layers are working? So, layer designs, so you can see the initial impact on the outer layer. The first layer deforms instantaneously. So, instantly that first there are, so this is the multi-layer 3 layer. So, when there is impact, this layer the main deformation comes, that this will deform, this is outer layer, inner layer, transferring the point of impact from the concentrated area to the wide area, that is the function of the first layer. So, here we need high strength fiber. So, surrounding fibers will start taking this main load, the impact load will be distributed to the wider area, then shearing and stretching will be there. The successive layers absorb the remaining kinetic energy through stretching, friction and mechanical distortion of the structure. So, gradually they will start absorbing the energy, and then in doing this by absorbing the energy, so then trauma reduction will be there. So, that person will be protected. So, final layer offers, so they are often designed to blunt trauma protection. So, after blunting of this knives, so their energy is reduced, and then this will be used as a last layer, inner layer, final layer will use as a shock absorption, and which will reduce the blunt trauma, preventing severe injury even if the blade is stopped just before the penetration. So, that this is the final layer. So, we use normally multi-layer structure. Next approach is that the next physics which we there are material science, it is a shear thickening fluid. So, this is very important, which we have discussed in ballistic protection also. Shear thickening fluid basically it is a non-Newtonian fluid, there will be non-Newtonian approach will be there to enhance the impact resistance. So, offering the soft flexibility until a high speed strike is there. So, when there will be high speed impact, that material becomes solid. So, otherwise it is a soft and flexible. Okay. Now, liquid state. So, this is the liquid state. where the under the normal load, normal condition at low speed movement, the fluid behaves like a viscous liquid. So, this is the normal viscous liquid, allowing the fabric to remain flexible and comfortable. So, if we incorporate shear thickening fluid here, that fluid becomes at its normal viscous and it will act as a normal, and fabric will act become flexible, and at high shear stage. So, when there is a shear rate is high, so upon high speed impact like stabbing, the fluid instantly transform to a solid like state. So, that solid like it will, and process known as shear thickening. So, shear thickening takes place, and the sudden solidification dramatically increase the material's viscosity and resistance of any penetration. So, which actually rapidly dissipate the kinetic energy imparted by the object like knife. So, this material is now being used in stab protection, and then balancing protection and comfort. We must have the product stab protective textile which will be flexible and comfortable. So, STF actually that does not increase the weight too much, keep the fabrics the porosity intact. So, STF typically impregnated into standard high performance textile layer, creating a hybrid composite that address the main requirement, key requirement. So, it enhance the flexibility as compared to other material, like if we use multi layer. So, 10 or 20 layers of same high performance textile material, that will make the total system inflexible, but instead keeping the number of layers low, but if we use the shear thickening fluid, so it will be flexible, unlike rigid plates or very large number. So, STF number of layers. So, STF treated fabric retain the drape, movement and improving wearer's mobility. So, it remains flexible. So, it comfort is maintained. Obviously, weight reduction will be there. So, it allows the lower number of layers. So, mechanical layering system. So, we can reduce the number of layer and it improves the blunting. So, due to the thickening, STF excel the stopping of sharp object, also significantly reduce the blunting force trauma. So, it becomes the due to the hardness at high speed, high velocity, the STF acts as a solid. So, that there will be blunting action will be there and blunt force trauma will be reduced. And next one is that biomimicry. So, nature inspired materials have been developed. Now, we can see the scientists and engineers frequently turn to biology for optimal protective design. So, they are to get idea, inspiration from nature. So, we can increase the protection, studying organisms that have naturally evolved high efficient armor system. In the nature we can get. So, we can say this is the insect which is very which are flexible, they can bend, at the same time the coatings are very hard to penetrate. So, this type of designs are created to have high stab resistance. Now, this is another design. So, that means, if we can have different plates arranged in certain order, like different plates arranged in certain order, the total system will be, the armor system will be flexible, but at the same time very high cut protection. Instead of a continuous block, if we arrange this is suppose a metal or composite, if we have flat composite, that will be inflexible, but if we can design this type of structure, this will remain flexible, but the stab resistance will be very high. This type of nature inspired materials have been developed. The key lesson from biological armor is the ability to combine the stiffness for protection with the flexibility for movement. So, that is what I have discussed. Now, here overlapping scales. So, there are different types of different examples, like fish or pangolin scale. The layers are designed to overlap, these designs are overlapped, allowing the movement, that is this overlaps design, they are flexible while presenting multiple angle surface. This multiple angled surface becomes an weapon. So, this is actually the penetration through this surface will be very difficult. Toughening materials are used, that the material scientists, they have developed different types of hard material, like mimicking the mother of pearl or bone structure material, which are light, but they are very strong and tough. So, these materials are engineered with internal microstructure, and that increase the energy absorption before fracture. So, this type of structures are developed, and that suppose this type of hard materials are used with this type of scale structure, then we will get very high stab resistance and also the structural hierarchy. So, designing textile with protective element at multiple length scales, from fiber alignment to scale placement. So, different types of approaches we can have to maximize the protection efficiency. Now, try to see the materials which are used for stab resistant fabric. Aramid obviously is very popular here, like cut protection or maybe ballistic protection. Para-aramids like Kevlar, Twaron offers exceptional strength to weight ratio, okay, providing a fundamental barrier against the sharp object, that is due to the very high strength. High performance polyethylene, high molecular weight polyethylene. So, it is known for superior cut resistance and impact absorption, often used alongside with materials like steel and glass core. So, that we have seen in case of cut protection that we can use here. Polymer coating is also used, like this fabrics are impregnated with specialized coating to enhance the stab resistance without adding significant weight, like shear thickening fluid we can add, and also 3D printed structures are also there. With advanced manufacturing allows for creation of new tailored polymer structure with internal geometry specially optimized for the cut resistant as a stab resistant fabric. Now, there are different types of testing standards which ensures the reliability of the product. So, there are rigorous internal standards ensure protective gears to achieve the performance. Now, this is one standard, German standard PPAM KDIW 2004, then it is, and in German there is 201. This standard measures the resistance against both kinetic impact and stab or spike threat for body armor. So, kinetic impact it can test, or stab or spike threats it can test. NIJ standard, so which is US protocol, specifies a detailed protocol for testing vest against different classes of knife and spikes. So, US this is widely accepted NIJ standard. Now, ASTM standard for cut resistance that we have already discussed in detail using TDM, because for stab resistance there is a after impact there will be cut also. So, for any stab resistance fabric we must also know the cut resistant characteristic, because the knife along with the impact penetration, during the penetration there will be cut. So, we must also add cut resistance. So, it is critical to note that the test differentiate between the threat posted by typical knives, different types of spikes or hypodermic needles. So, this type of threats are there, then for this we need these standards. So, NIJ standard 0115 that is widely used, and cut, as I have already mentioned, we have already discussed in previous section. So, we will discuss in detail the NIJ standard. So, method is dynamic test method, where this test use the drop tower to simulate the energy of stab. So, energy which simulates the energy speed in the real world, a forceful stabbing motion measuring the penetration depth. So, that this is widely used, that is dynamic test. Along with that some quasi static test is there. So, which actually penetrates at slow speed. So, a slow controlled force is applied until the penetration occurs. So, that force is measured here at slow speed. Use preliminary normal any standard instrument, UTM also we can use. To this measures the material's maximum static resistance. So, any pointed object or any knife will penetrate gradually, so that it will measure the force required, and for all this test we need, particularly for dynamic test, we need backing material like the ballistic test. So, backing clay or similar materials are required, which is placed behind the fabric to accurately simulate the human tissue. That backing material will be there, and where we would like to assess the injury, potential injury from the penetration. So, backing material is also important. So, there are different types of backing material, there are standard arrangements of backing materials are there, that we will discuss subsequently. Now, as per the NIJ standard, the stab level, so of body armors are classified into 3 levels: level 1 armor, level 2 armors, level 3 armor. In level 1, it is a low protection level, okay, and which are suitable for extended wear, which will be lightweight, mostly used for private citizen, where there are threats from stab are low. So, this is basically for private citizens they can use, and duty garment for extended wear, covert or overt. So, here for security personnel this will be typically little bit lighter, but threats are more than the level 1. So, these are used for by the police or security personnel, and high risk zone. So, it is called overt, where mainly for army and defense personnel. So, this stab protective textiles are mainly combination of the this ballistic protection with the stab, okay, for high risk zone. Level 3 is there. Now, there are different types of blades used in the NIJ standards. Basically 2 types, P1 type and P2 type. So, in NIJ standard, the edges of blades are classified like the P1 type, P2 type. Let us see what is P1 and what is P2. So, these are used for, this test is for protection against high quality commercially machine edged knife blade. These are, they are actually machine edged knife standard blade, not necessarily the actual used blade will be the similar, but for standard we use standard result, standard test we use these 2 types of blades, P1 and S1 type, and these are the edged surface where penetration along with the cutting action will be there due to the edged surface. Okay. And another is the pointed surface, the spike class, where only points will be there and at the edge there will not be any cut, only the frictional resistance will be there. So, the main threat here is with this type of edged blade, because it penetrates through the tip, but at the same time it keep on cutting. Okay. So, here both the penetration resistance and the cut resistant textile should be there. Protection against low quality knife or spike style weapon. Now, let us understand the labels, their protection level. So, for protection level 1, there are two types of striking energies are there. So, E1 strike energy and E2 strike energy for different types of protection. So, level 1 is the protection against low energy threats, and for E1 means the penetration should be less than equal to 7 mm, and at high energy if it is going. So, then it will be E2 less than 20 mm. Okay. So, level 1, which actually in for E1 the energy for penetration energy or strike will be around 24 plus minus 0.5 joule. Okay. And if we convert into feet pound force, it will be 17.7 plus minus 0.36. And when we go to the E2 level, for level 1, this will be 36 joule. For level 2, little bit higher protection, for that it has to withstand the penetration energy of 33 plus minus 0.6 joule, but at that energy the penetration should be, if it is less than equal 0.7 millimeter, then we will call it as this level 2 E1 strike energy, and if it penetrates less than equal to, it is a more penetration is there, then E2, it will be E2 level, but here the penetration energy is very high. At very high energy, if we have level 2, and at that case we should allow less than 2 centimeter, actually 20 millimeter penetration, and level 3, if we allow less than 20 millimeter, so it should withstand 65 joule energy. So, there are clear guidelines of the penetration protection level. So, along with that we will set our test protocol and we will test the penetration for a certain strike energy. There are two standard strike energies are there, E1 level strike energy and E2, and E1 there are 3 different levels for level 1, level 2, level 3. For E2 strike energy also the little bit higher level, where we allow little bit more penetration. So, that level 1, level 2, level 3. Now, the basic thing is that suppose we are trying to develop level 3, we are trying to level 1 protective textile as a level 3. There at lower energy level. So, like this is the E1 level 43, if we are punching it, you are striking it at lower energy level, standard energy level 43 plus minus 0.6, then the if the penetration is less than equal 0.7 mm, then we will call it as level 3, and if we increase the energy to 65 plus minus 0.8, in that case this same level fabric, same cloth, same protective vest may exceed the penetration level beyond the 7 mm, but it should be less than 20 mm, then we will call it as level 3 garment. So, these are the standard, based on this standard penetration energy we can grade our the fabric as a level 1, level 2, level 3. So, we will continue with this detailed test protocols and standards. So, in the next session, till then, thank you.